Here are some operations that we can do with sets. I have my universal set here, lowercase letters A through J. This is the entire universe as far as I'm concerned. I don't care about anything else outside my set. This is the whole universe. So when I come down here to set A, the set of vowels, this is the set of vowels in my universe. So I'm going to make a list, A, E, and I. O and U, as we know, are also vowels, but they're not in my universe, so I'm not going to put them in A either. Then I have the set of letters after E. Well, that sort of brings up the question, well, does that include E or does it not? Ask the question, is E after E? Well, no, E is exactly where E is. It's not after E. So we're going to start after E with F. Here's set B, F, G, H, I, and J. The autocorrect really wants this to be a capital I every time I type it, but it's really not. C, we already have, so we don't have to worry about figuring out what's in C. If you want to, you can put sets like this into a Venn diagram. I want to, so let's see what that's going to look like. I'm going to draw my rectangle for the universe. If you don't want to, that's okay too, if you can figure out what the sets are without looking at the diagram. But let's go ahead and do it. So 3 circles for set A, set B, and set C, and the rectangle is my universe. I'm going to put each of those 10 letters into my diagram one time and one time only. So we're going to make sure it's in all the right places at the same time. I'm going to notice over here, I is in all 3 of my sets. It's in A, B, and C, so I'm going to make sure it's in all 3 of the circles. Right there in the middle, there's I. E is in A and C, but not B, so I'm going to put E in circle A and circle C, but outside of B. That'll be here. A is only in A. Let's put that one there. Looking at B and C then, that takes care of A. Nothing else is going to go in circle A. In B, I have in B and C both, I have G and J are on both lists, so let's put those in the intersection of B and C. Left over in B, I have F and H. And left over in C, I have C. If I count those up, though, that's only 8 letters, and I need to have 10 because there's 10 letters in my universe. So the 2 that aren't in any of those, aren't in A or B or C, are B and D, and I'll just put them somewhere on the outside of all the circles. So there's my Venn diagram. If it's useful to you to look at that as we go through this, by all means, you certainly can. Some set operations. Lowercase n is the technical term is the cardinality, but all that means is the number. The number of elements in set A. So I'm going to count out the elements of set A, E, I, 1, 2, 3, and done. Maybe with an equal sign, then we'll be done. When we talk about the union of 2 sets, it is again a set, so we do have to put curly braces around it. B union C. When you see union, think or. A union is everything that's in one set or the other or both. So when I see a union of B and C, I'm going to take everything from B, everything from C, and throw it all in together into one big set. B union C, I need C and E and F, and then all the way out to J. If we look at the Venn diagram over here, that's everything that's in circle B, circle C, or both. Intersection, on the other hand, the intersection of 2 sets, think and for intersection. Everything that's in both A and C. So if we're looking at the list, I'm looking for what's on both A's list and C's list, and I see E and I on both of those lists. If we're looking at the Venn diagram, we're going to look at this kind of football shaped area here where A and C overlap, and we see E and I in there. There's A intersect C. C with the bar over top is C complement. We have a couple different ways of writing complements. This is one of them. C complement is everything that's not in C. Everything in the universe that's not in C. So when you see complement, think not. If I look at my diagram over here, I'm going to cover up circle C with my hand. I'm doing that. You can't see me, but I am. And just take the things that are outside of circle C. So I see A, B, D, F, and H outside of circle C. The difference of two sets is I kind of think of without, A without B. Everything that is in A that isn't in B. Well, the only thing that A and B have in common is I. So A without B, I'm going to keep the A and the E, but not the I, because I want A without the things that are from B. We certainly can let all of the sets play at the same time. If I say A union B union C, that's throw everything in together. Looking at the Venn diagram, that's everything that's inside a circle, any circle. So A, C, skipping over B, skipping over D, because those are outside the circles. But everything else is in there. Well, then I have A union B union C complement. The good news is we just found A union B union C, so I want the complement of that, everything that's not in that set, that is in the universe. Well, those are the ones out here. If A union B union C was everything inside a circle, then A union B union C complement is everything that's outside a circle. So take those for the complement. A intersect B intersect C is, I'm going to, intersection again means and, so things that are in A and B and C, ones that all three sets have in common, that's the middle there, and that's I. You really do have to write the curly braces every time because these are all sets, the results. If you're not good at drawing curly braces, just like go like this and I'll know what you're talking about. Last one here, A intersect B intersect C complement. Well, let's see. A intersect B, A and B intersect here, and the only thing in the intersection is I. I'm going to look at what this is sort of an in-between step. A intersect B, and that's just I is the only thing in there. I'm going to look at what that list has in common with my C complement list, which is up here. Let's see, I and A, B, D, F, H. Well, they don't have anything in common. This must be a job for the empty set. There's nothing in there. They have no elements in common, so the intersection is empty.